Welcome to this demonstration of EdgeXConnect. In this demonstration, we will import an OPC UA companion specification, create an instance of an object type from this companion spec, map the object to a Modbus type edge device, and also configure a method. It is recommended that viewers also watch the EdgeX Getting Started demonstration, which covers how to install and configure a simple solution.
So we are showcasing some of the feature of the EdgeXConnect platform. I installed the system on my Linux laptop, Windows laptop. EdgeXConnect can be installed on Linux and ARM Linux. I have the EdgeX server running. Windows it will run as a set of services. And let me sure that it is in fact operating as expected. The default port is 54,000. That's also configurable. I'm going to connect with the generic OPC UA client to the anonymous endpoint, and I can see that I can connect and see the address space in which we deploy a set of test variables that are connected to our simulator adapter, just to see things moving right out of the box. It doesn't do anything of interest, but that tells me that all the services are operating as expected. I'm going to disconnect now, and I'm going to go to the modeling tool. The EdgeX Studio, it's both used for modeling of information models and configuration of an EdgeXConnect server. Just verifying that I have the latest build, and I am properly licensed. The evaluation license will limit the number of nodes that I can map to an I/O data source. In my case, I actually have a legitimate license. The one thing I can do, I can create a new project, a new information model, a new configuration. But what I'm going to do today is I'm going to connect to EdgeXConnect server. And in this case, it's running on my local machine, so everything is set up. And if I import the configuration, EdgeX Studio is going to look for that server, is going to download the running configuration, and here I have the address space and all the information models associated with it. Of course, I have the default namespace 0, which is the OPC Foundation types, and then I have my user namespace, which we call test, that basically includes all the demo variables. One thing I can do here, I can extend my address space to do a couple of things. One will be to include a companion specification, an existing information model, import it in my address space, so I can take advantage of some industry standard that publishes a companion specification and an information model. And then I will create an instance of the types that are defined by that standard, and I'm going to map them to an actual I/O source. I will use a Modbus connection, in fact, a simple Modbus simulator that I can run to simulate a TCP, a Modbus TCP server. So in order for me to import a companion specification, I just request the importing of a model, and I'm going to go to the set of companion specifications that are published and maintained by the OPC Foundation. The one thing that I'm gonna import the device integration companion specification, and I just select the node set, and that should add that in the list of my available namespaces. it would include that in that list of models. And I can also see that it also created the default instances for that particular device integration model to include the network set, the device topology, this folder that organizes feature and things like that. And on top of that, I will also look for the process automation device integration model, which is also maintained by the foundation. The PADIM, request mandates the importing of the IRDI model first, and then the PADIM. What I'm doing here, I'm assuming that I know these companion specifications. I'm looking for something that would define the types for sensors and process automation objects, but I can also integrate it with other companion specifications that are more vertical related, specific industries. So now that I have the PADIM, I should be able to see the signal types. And the signal type will give me those object types, like an analog signal, a discrete signal, multi-states, two states, and what have you. So I can create instances of these objects. I'm going to take the analog signal type, for example. And the analog signal type includes a method to calibrate and adjust the 0 point, and then a variable that I can use to actually map this value to a Modbus register in my simulator. So I can go into the objects part of the address space and instantiate an object. And the namespace of my new object, I'm going to put it in my test namespace, the user namespace. And I'll call it analog signal 1. And I'm going to map it to the signal type of choice. In my case, the analog signal type. Once I do that, EdgeX Studio will create the instance of that object, and of course it will also include all the required attributes. We don't care about this method yet, but of course in EdgeXConnect, methods can not only be modeled, but can also be implemented via scripting. We can show an example of that later. The signal tag of a signal type, you just represent the string. I don't need to map it to anything particular for now. I'm interested more in this variable. That's what I want to map to my Modbus simulator. And the first thing I'm gonna check is this. This is a variable, and it's a signal variable type. The data type is a number. I want to be a little bit more precise. The number of interest being a Modbus register. I'm just gonna go for an unsigned integer, 16 bits. I'm gonna just verify that everything is in order here. I'm gonna make it so that, well, the sampling interval is 0, so I don't have a minimum. I'm gonna make it writable, and I'm gonna save it. The only device I can map by default is the simulator device from the simulator adapter. So I need to configure a new device that actually uses the Modbus TCP adapter. And I do that through the devices tab. I'm going to call this thing Modbus TCP device. The adapter of choice is the Modbus TCP adapter. The pool size is just an optimization of the threading model of EdgeXConnect. So it basically configures a thread pool of a variable size depending on the capability of the computer. Then I'm going to set the IP. This localhost, the default port for Modbus is 502, and my slave ID is probably 1. The endianness should be a big endian, but we're going to see that. I'm going to save this. Here's my Modbus TCP device. Therefore, I can now map to a Modbus TCP device, and this value is an analog value. So it's going to look for the reading of a holding register. The address 1 is basically the first register in the array, like 40,001. So I'm going to map it to that, or sorry about that. The other options that I have are all the parameters that I might want to configure in an I/O mapping scenario, like scaling. I'm not going to enable the scaling for now. The cache is another optimization for the communication. It would buffer the communication to limit the latency. I'm going to leave it as a default. So okay, so I should be okay. Of course, this mapping data relates to a Modbus device. If it were a different device, you would have different properties probably. Save that, and the project is being successfully saved. I can now deploy the system. In fact, I went too fast, but now that I have committed the changes to my address space, I can push this button that does the inverse of actually deploying the configuration to the EdgeXConnect server. And once it deploys, it also restarts the services in order to start running and mapping the new configuration. I'm going to wait until the server actually restarts. I'm going to then connect with the OPC UA client. So let me connect. The server is restarted, and now I can see that I have everything that I was expected, plus all the DI objects and my analog signal, which is an object of which I would like to see this variable. And the variable, as you can see, it's basically now getting the value changed by the simulator. If I do this, I can probably, for example, zero the value. I can change this value to something on the Modbus side, or I can write on the OPC UA server side and put 100 right here, and the simulator should start counting up from there. There it is. So it writes correctly. So that's how you can quickly instantly implement an OPC UA server, configure it, modify, import information models, map them, and get it going. Another thing that I might want to showcase is the methods. Now I'm not gonna implement a 0-point adjustment here. I just thought this is a method that does not have an implementation for now. It's just a blank method, and the call would probably generate an error because there's no handler for the method. And just as an example, let me just disconnect the client. I'm just going to implement this particular method in the Lua language to add the two numbers and return the sum of those numbers. So to better visualize the logic of my method here, I'm going to be putting the Lua script in this text box here to make it easier. I actually use this editor that can highlight the syntax, and I'm going to go through the method. In EdgeXConnect method handlers, basically require the implementation of a function called execute methods. Let me just delete. That's the skeleton function. It's called execute method, and it will require input parameters and output parameters that can be handled by this method execution. The EdgeXConnect scripting engine will detect and associate this logic with the call service for that method from the OPC UA client, and it will do whatever I program it to do. It uses the Lua language, which is very convenient and easy language. It's a one-page tutorial, and it's used in a lot of software applications, especially the ones that run on embedded system. It's very easy, very versatile, and it's very good for scripting. I have a few things here, a few commands that print to the standard output. If I want to write to the login facility, but the main part is that I have two input parameters, call it input 1 and input 2, and these specialized EdgeXConnect functions in Lua that will go and get those input and output parameters and get the values, set values as we see. The input parameters and the output parameters are arrays of parameters. So I go by index. I take the first parameters in the input parameters list, and I will associate that variable, and then I will get the value that is coming as an argument from the caller of the method. I do the same thing with the second parameter, and then I will just calculate the addition of the two values, and I will set the only output parameter that I have to that summation. There's going to be documentation. This is a simple method. You can do more complex logic. It would take probably too much time to go through that demonstration, but basically it's a Lua method that can be parameterized and used by the EdgeXConnect. So I'm going to copy it into my scripting editor, and then I'm going to define the input parameter. I'm going to call the first one, I need two input parameter 1, and the data type, I'm going to say it's an integer 32. It's a scalar value, it's not an array. Let me just add a second parameter, which is the secondary parameter 2. This is the other addendum. Integer 32, okay, about the description, and I need one output parameter, which is output parameter, data type, integer 32. Well, should be 64 probably. Why not? And the description is not relevant now. I'm gonna save it. And now I have a method implemented. Everything is successfully saved. I'm gonna go ahead and deploy the configuration again. And that will do the process all over again. It's gonna upload the new configuration of the address space to the EdgeXConnect server. And once it's completed that operation, it will compel the EdgeXConnect server to restart. When I have this message, means that the services on the destination server are restarting. So I should be able to connect with an OPC UA server client and see it. So I'm gonna reconnect. I have my analog signal. My signal is still coming through, And now I have this 0-point adjustment that should be used to adjust the 0 point. But in my case, it's a method that implements the addition of two values, 2 plus 3, I call it. It executes the logic in the script and it returns the expected value. These basically demonstrate most of the key features of an EdgeXConnect implementation. And again, now you do have a complete OPC UA server with information modeling, advanced information modeling. You can import information model, you can create your own information models. And when you do, you can also create your information model and export it as an OPC UA standard node set. You can then instantiate the types and the objects of that particular information model and map the value to an IO data source. Moreover, when it comes with methods definition, which are an important feature of OPC UA modeling, not only you can model the method, you can also implement the logic. That makes it easy to implement an OPC UA server without having to compile any particular code. That covers some of the fundamentals of EdgeXConnect. And till next time.